Well, good morning, everyone, and welcome to today's webinar. The webinar today is entitled, How Does Walking Time Between Workplace and Parking Affect Commute Mode? A GIS-based commuting model with Omid from Victoria University of Wellington. And we also have a presentation from our partner, AllTerra. So my name's Claire Thello from Eagle Technology, and I'm going to be the host for today. I'm joined by Greg Price from Eagle Technology, Jonathan Davies from Trimble, and Helen Munro from the New Zealand Esri Users Group. Thanks for joining us for the fourth session of our user presentations as we continue with the New Zealand Esri Virtual User Conference series, following on from last week. For those who are new attendees on our webinars, I'll just go over some basics so you know how to participate and get the most from today's event. As an audience member, you will be muted during the webinar, but you will be able to ask questions by typing into the discussion panel shown here. You may send your questions at any time during the presentations. We will collect these questions and answer them during the Q&A session at the end of today's presentation. We will try to answer as many questions as possible within the time allocation, but if we don't get to your question, don't worry. We will pass all unanswered questions on to the presenters at the end of the webinar so they can reach out to you. If you think of any questions after the webinar, you can drop us a line at gistraining@eagle.co.nz or feel free to touch base with the presenters directly. Today's webinar is scheduled to run for an hour. If you need to jump off at any stage, that's totally okay, as this video will be recorded. You'll receive a follow-up email with a link to access the recording, along with other recordings from the Virtual User Conference series. Likewise, if you have any colleagues who are unable to attend today, they can access the recordings online as well. Now I'd like to introduce Omid from Victoria University of Wellington. Good morning, Omid.
Hello and good morning, everyone. So thanks very much for listening to my presentation. So I'm Omid from Victoria University. I'm doing my PhD in GIS. I use GIS for transport modeling and transport research. So the research I'm presenting today is about parking at workplace. So specifically, I ask, how does walking time between parking and workplace may impact choices of commuting? So let me just okay. So when we think about commuting, and especially a car trip, we tend to think about a trip that starts from home and ends at workplace. However, if we look in details, we actually drive from home to a parking at workplace and then walking from parking to workplace. So this second part of the journey has been almost neglected in parking studies, and this is the focus of my research here. So specifically, I ask, how does this walking time between parking and workplace may impact choices of commuting, either driving, using active modes of transport, or public transport? So I have some contributions to parking studies in addition to the main focus. So I choose residential location as choices for commuters in my model. So we know that parking at home may impact number of cars or preference for a commute mode. But the point is, the number of cars that a household currently owns or their preference for car ownership also impact their decisions on where to live. So I consider a set of residential location choices for commuters in my sample to choose. The second point is that I consider different travel modes for commuters. So it's not just a binary choice like driving against all other modes. Instead, I have choices of driving, active transport, and public transport as commute mode choices. Also, I consider travel time as a measure for commuting length in this research because this can better represent commuters' perception of length. And the last point is that my case study is a region, including a main city and some other urban and rural areas. And this is because commuting is actually a regional issue, and so it's not limited to a single city. So some of these points have been considered in some of the research, but separately. In this research, I'm going to consider them all together to have a better and more realistic approach to parking. Okay, my case study is Wellington region that I assume you are all familiar with. And Wellington City as the main city of this region is interesting in terms of parking studies. There are 3 different areas in the city in terms of parking availability and regulations. The first area is Wellington City Centre, or CBD, which is a compact area, and parking both off street and on street are pretty restricted, and commuters have to pay for that. Parking is very competitive in this area. The second area is coupon parking zone. Although this area is less congested compared to CBD, but still commuters have to pay for on-street parking. And the third area is actually areas outside a coupon area, so abundant free on-street parking available for commuters to park. So because of this situation, Wellington City sounds an interesting case for parking study. So my data actually comes from New Zealand Household Travel Survey, and my measure for residential location is mesh block in each area unit. My sample includes commuters that work in a fixed workplace in Wellington City, and they live in Greater Wellington region. So to estimate the impact of parking, I use a conditional logit model. So in this model, dependent variable is actually choices of commuters. So they can have choices of commute mode, choices of car ownership, and residential location choices. So dependent variable takes the value 1 if the choice observed in data and 0 otherwise. The main function here is utility function. So I estimate the coefficient of each explanatory variable, which is actually explains the partial effect of that explanatory variable on the choices. So I calculate probability of making each choice, and then I use maximum likelihood method to estimate this partial effect. Okay, so the most important explanatory variable here is parking variable. Before collecting data on parking variable, I need to set a frame for collecting data. And that frame here is maximum walking time between parking and workplace. So here is a bit tricky here in this research. So I start with an initial time, like 5 minutes between parking and workplace. I collect parking data within these 5 minutes for each workplace, and then I run the regression model and get the results. Also, I repeat this process with slightly more or less walking time, and at the end, I compare the results to make a conclusion. So to calculate walking time, I actually snap workplace and parking to a walking network I'm using, and I calculate walking time between these 2 snapped points. And at the end, I calculate average walking time between each workplace to its nearby off-street and on-street parking as main explanatory variables in the model. So because commuters think about competition on parking or demand for parking in addition to walking time to parking, I calculate weighted average of time with respect to demand, and I use this variable instead of time in the main regression. Also, I control for parking availability and cost. I also control for demographics and built environment features. Okay, I divided my sample into two subgroups. The first subgroup includes commuters that have access to off-street parking buildings at their workplace. So they are mostly commuters that work in Wellington CBD and partly in Coupon area. So as you can see from the results, they prefer to use public transport. So driving is not a favorable commute mode for them because of restricted parking at their workplace. And they also want to live as close as possible to their workplace. So for this subgroup, when walking time between parking and workplace is pretty small, they prefer driving over other modes. However, if this walking time starts to increase, they prefer public or active transport over driving. Also, demographics have some impact on proclivity to drive. For example, having children or number of full-time workers in a household or the age of head of household all have positive impact on preference for driving. Commuters that work in Wellington CBD, which is compact and restricted in terms of parking, driving is not a favorable choice for them. Also, another point here is that income doesn't have a significant impact on commute mode. This is one of the interesting findings of this research so far, and this is in contrast with common ideas in parking studies. Okay, the second subgroup are actually commuters that work outside Wellington Coupon area. So abundant free on-street parking available for them to park their cars. And because of this abundant parking, and so like a very few demand on that, as you can see from the results, parking is not a big issue for them when deciding for commute mode, but instead their decision on commute mode and specifically driving could be explained by some demographics, like for example, having children has a positive impact. Also, income plays an important role here, and also the age of driver. Yeah, so thanks very much for your time. So this is actually an ongoing research, so still some work needs to be done. So that was my progress so far. So I appreciate your comments on my presentation. Thank you.
Thank you, Omid. That was a really interesting and topical conversation in today's climate and world. You mentioned just at the end there, what are some of the things that you're looking to continue with your?
Sorry, I think I lost your voice.
Sorry, what are some of the topics or areas of further investigation that you're looking to do?
Well, this is one of the papers in my PhD. So for this paper, I actually need to work furthermore on collecting data in different maximum working time frames, as I explained in some of the slides. I can show you here. It's like what was it? This part. So, for example, the results I presented today was for data collected within 5 minutes working, but then I have to like repeat this process for example 7 minutes, 10 minutes, and then I compare the results. So this is I'm currently working in this part of research.
Oh, that's very good.
Yeah.
We look forward to hearing more about that and you know how you finalize and any results you get from it. Was there any surprises in the results you got so far?
Well, one of the surprises that I mentioned, like, is then impact of income on parking, as you can see from this slide, because traditionally it's believed that like park income has a significant impact on choice of driving. But like this is one of the interesting findings here in this research, that like parking has a more significant impact on driving rather than compared to income.
Okay, that's interesting. And do you think some of these results could change the way councils allocate parking or price them?
Well, it's actually a bit early for me to answer this question, because as I said, like I need to run this model with some other working time frames, compare the results and interpret them. But yeah, so to be answer this question fully, like other parts of my research focuses on parking at home. So I think at the end I can just compare the results of parking from home and also parking at workplace, and then I will come and hopefully come with an interesting conclusion to help improving parking policies here in Wellington.
Okay, fantastic.
Thank you.
Anyone else out there who has any questions they would like to ask Omid at this time?
So Greg, I might just jump in there. We do have a couple of questions, but we might hand over to Jonathan so he can do his presentation and keep the rest of the questions to the end of the webinar.
Sounds good.
So let me just swap over to Jonathan. Thank you so much, Omid. That was fantastic. Over to you, Jonathan.
Thank you. Hopefully you can see my screen. Can someone confirm?
Yes, we can.
Okay, great. Thanks a lot. So hi everyone. Thanks for the opportunity just to give you a quick update on Trimble today. We're very happy to be supporting the New Zealand Esri user group, and we were planning to attend all of the regional user conferences this year. But you know, in the light of current events, you know, we're happy to be here today to give you the short update anyway. And you know, as everyone else is, I'm working from home, so hopefully my internet connection holds up and we get through. But I won't take up too much time. I just wanted to spend a few minutes giving you a quick update about Trimble. So as I mentioned, my name's Jonathan Davis. I've worked for Trimble for about 20 years now in a variety of roles. My background is as a surveyor coming out of Otago University. And I started working for Trimble in Christchurch and then got the opportunity to work in a couple of different places, but now find myself working remotely from my home office in Blenheim. And I'm leading sales activities for our GIS business across the Asia Pacific region. And in New Zealand, our local reseller is AllTerra, and I'm working closely with Warren Eade, who I'm sure a lot of you know, who is managing the GIS segment of the AllTerra business. So I've got his information up on the screen there as well. So at Trimble, we celebrated our 40th anniversary in 2018. The company was founded in 1978 in Silicon Valley in California. And the company was really established on GPS technology, as I'm sure most people know. You know, the Trimble thing was the yellow GPS, and we started by selling GPS into the marine construction segment actually, and then quite soon after that into sort of the surveying and mapping profession. But since then, the company has matured and really grown up, and now we do more than just sell GPS. We still sell a lot of GPS, or what we now call GNSS, with the addition of the various constellations. But we have more sort of industry-focused solutions that include GPS or GNSS and other hardware technologies, but the company now is actually about a third hardware, a third software, and a third services. And the industry segments on the screen are where most of our focus lies. But if you look across the whole company, there's about 30-something businesses that totaled last year about $3.2 billion in revenue. If you look at how the teams are spread across the globe, when I started about 20 years ago, there was about 1,000 employees, primarily in the US. But now through organic growth, but also through the acquisition of a lot of different companies, we're at about the 12,000 mark for the number of employees. And I just wanted to point you down to the bottom right. This is a map that New Zealand actually features in. We haven't been left off this map. So New Zealand it's well in excess of 400 employees up and down the country. The original Trimble office where I started was in Christchurch, developing all sorts of things. But I started off in the survey controller team. But it's an office where a lot of our mapping and GIS solutions have been born as well. So a lot of the software, a lot of the GeoExplorer products that I think a lot of people are hopefully familiar with have all been, or a lot of them have been born out of Christchurch, and that includes several of our emerging technologies today that the company continues to invest in. A lot of it comes out of New Zealand. So I just wanted to highlight the fact that New Zealand plays a very, very important role in the global company. If I just quickly look at the relationship between Trimble and Esri. So Trimble and Esri are global strategic partners. If anyone's been lucky enough to attend the Esri, the Global User Conference that is in San Diego every year, every July, then there are usually two very large booths in the trade area. One is Trimble and the other is CityWorks, the other platinum sponsor of the event. And CityWorks was actually acquired by Trimble late last year. So in terms of strategic partners, Trimble is certainly one of the larger partners that Esri has. And naturally, we collaborate across our product teams, and that the outcome of that is several points of integration to help streamline customers who are mixing Trimble and Esri technologies. And just a couple of examples that I think are relevant for this group are, start on the right-hand side. Trimble obviously sells mobile devices, and if you want to improve the accuracy of the data or the spatial accuracy of the data that you're collecting, you can choose to add a GNSS component to that as well. So one of the outcomes of the collaboration of the product teams is that Collector has native support for Trimble GPS inside the software, and then Collector can obviously run on the Trimble devices too. So that's just one example where the technology across the companies can come together. And then on the left-hand side, Trimble develops an add-in for ArcGIS desktop called Trimble Positions. And from Trimble Positions, you can create jobs or create data collection jobs and send data from your GIS out to the field, to the Trimble solution, and then bring it back into your GIS as well. And the point of, one of the important points to highlight with Trimble Positions is that it gives you the ability to post-process your GNSS data within the Esri environment. And by doing the post-processing, increasing the accuracy of the data that you're collecting. So I'm not going to jump into post-processing technologies and the various GNSS technologies or principles underlying that, but just know that Trimble and Esri are collaborating on a number of different fronts to streamline the use of technologies from both companies. So jumping into a couple of the Trimble technologies, we've got a whole range of data collection technologies that go from mobile tools that I think a lot of people on this webinar are familiar with for capturing information about individual features, all the way through to 2 million point per second scanners that you mount on the top of a vehicle and drive down a highway, for example. And I think most people associate the tools on the left, the mobile tools, with GIS data collection, and then the tools on the right more with engineering type applications. But there are actually a lot of, there are some workflows, sort of GIS-oriented workflows using the technology on the right-hand side, where using our software, you can extract information about features up and down a road alignment, for example, as a way to populate a GIS, and then you can use some of those mobile tools for the maintenance of that information down the line. So anyway, a whole range of data collection technologies, and if we show that by sort of show a similar chart but break it down into product category, across the top there are some of the more traditional types of solutions that I think a lot of people are familiar with: the integrated handhelds, the GNSS, the mobile devices. And then across the bottom are some of our, what I sort of call some of our more emerging technologies, pushing into the augmented reality space. Trimble Catalyst, which is offering GNSS positioning capability on your phone, sold via an on-demand subscription model. And then some of the other more rapid data collection technologies that I've already mentioned. But just some that I wanted to highlight for this audience. Firstly is the TDC 150. So that's an updated integrated handheld, which is sort of our next generation flagship solution past the GeoExplorer product line. So if you've got a GeoExplorer perhaps running TerraSync, then the TDC 150 would be sort of our next generation solution from that, which is running Android and can run the Trimble TerraFlex software for a cloud-based solution, or it's capable of running some of the Esri mobile apps as well. Or if you're not looking for that integrated device and you want a more of a generic sort of multi-purpose device, then the TDC 600 is an Android-based device that doesn't have that integrated GNSS component. So that's something that's a little bit smaller, lighter, that you can integrate with external GPS receivers if perhaps that's your preference. And then down below, some of the emerging technologies. I've run a couple of webinars the last couple of weeks that that this audience has been invited to, at least. Just hopefully some of you had the opportunity to join me a couple of weeks ago, looking at the sight vision technology, and then last week looking at the Catalyst GNSS capability available on demand as a service to your mobile device. What I wanted to just give a quick overview of for the next probably 2 minutes or so is Trimble Sight Vision. So Trimble Sight Vision is something that we've been taking to trade shows for the last year or so. It's been available on the market, I think, since December last year. And that is, sorry, I was just going to say, I think we had one at the Esri, or at the Eagle/Esri user conference up in Auckland last August. So anyone that was up there might have had the chance to see it as well. But it's an augmented reality system, and what's really unique about this is that it's integrated with high accuracy GNSS, and it gives you the ability to use the AR system outdoors. And that's something that usually these types of technologies are designed for more confined environments, not necessarily indoors, but more confined environments where there's structure and objects around the place that the technology can use to locate itself. But this system is one that really works well in that outdoor open environment. what it allows you to do is visualize digital data sets in the context of the real environment out on site. And through the integration of a laser distance meter into the handheld, it also lets you interact with those digital models as well. So the various technologies that come together, firstly, it really relies on the AR capabilities of the Android device. But when you pair that with the high accuracy GNSS and also the electronic distance meter that's in the back of the device, it really becomes a powerful unit that allows you to visualize your 3D data sets in that outdoor environment. But I think pictures usually tell the best stories. So I've just got a handful of pictures here to wrap up. And this is showing you the display of the device when connected to the Sight Vision unit. And it's going to run through a series of situations here where we are looking at things that are, or we are visualizing things that are hidden and things that are not yet constructed, just to give you a feel of some of the ways that it can be used. So in this instance, you know, something that's supposed to be hidden most of the time are underground utilities. And this screenshot just gives you a feeling for how Sight Vision allows you to visualize those underground utilities. If you've got a new house project, for example, so you might have got a CAD drawing from your architect. Well, this picture here, that house is actually a digital CAD model that's been loaded into Sight Vision. That's a empty site, and that house that's on the site is actually the model that's being viewed through Sight Vision. If you move into the space where the model exists, it actually gives you the ability to even see out the windows. So when you're collaborating with your architect on the view, or you know, the height of the windows, the height of the fence, or whatever it might be, it gives you a lot more context and understanding of, you know, what can be quite complex data sets, certainly more than a 2D plan. Could be a road alignment, so checking for clashes in infrastructure before you break ground. You know, it can save a lot of cost and time overruns. Or it could be, say, an environmental impact study for new or above ground utility lines that are proposed to go through a certain site. And this is one that I created actually for my webinar last week, which is just a sort of a pretend scenario, but I took a wind turbine from our SketchUp 3D warehouse and put it on the hills, or put this one on one of the hills near where I live in Blenheim. But it just shows once you put an object, or once you load an object into Sight Vision, and because you're using the RTK or 1 or 2 centimeter accuracy, or the system is able to leverage the accuracy from the GNSS, the model is really, it looks like it's glued to the ground. So this is just trying to show that as you move around the site, the model is there in your display, just as if it was a physical object on site. And then, in addition to things that are hidden or things that are not yet constructed, then another possibility is to load what we call a thematic map. So in this instance, it's a color-coded cut fill map, which has been draped across a terrain model and tells the site supervisor, you know, how much work is remaining from a cut and fill perspective, which is increasingly important in these construction sites, you know, when there are fewer and fewer stakes as the models are being loaded directly into the machines, rather than having surveyors running around banging pegs in the ground. So a very quick snapshot of you know, a couple of different technologies within the portfolio. Certainly a broad range of technologies there, and I hope that was of some interest to the group. So just finish with my contact details and also the contact details for Warren there. If you want to follow up on anything that I discussed in the last 10 minutes or so, then please just feel free to contact either Warren or myself. Thank you very much.
Thank you, Jonathan. That was really insightful. We're going to go back and just have a Q&A now for a moment. So I've got some questions sitting here, and Greg and myself are just going to sort of tag team the questions. So the first one is for you, Omid, and it's from Sam. Can you think of any other urban areas that might be able to reuse this model, be that in New Zealand or internationally?
Well, I think this model could be applicable to many urban regions, because in Wellington we have like a different settings, like we have a main compact city, and then some surrounded by some like almost low density urban and rural areas. So I think, given as far as I know from New Zealand, like this could be applicable to some other urban regions, because this is actually the same with some regions in New Zealand as well. Yeah.
Cool.
Okay.
Thank you. Yep. So I've got another one here for you, Omid.
Yeah.
In the future, how do you see the variables or coefficients changing, or would you see any change in response to more people working from home following the COVID-19 pandemic? And do you think there needs to be a tweak or some sensitivity analysis to allow for that?
Well, COVID-19 situation is quite different situation in terms of commuting these days. It's like, I mean, I'm sure like we'll have a different results if you run this model in this COVID-19 situation. Say, for example, like, I mean, as I said, like the focus of this research was walking time between parking and actual workplace in CBD. So if you work from home, then like this maybe it doesn't matter for many commuters. Yeah.
Thank you.
I think we'd hope to see everybody was at home at the moment, unless they were an essential worker.
Yeah. Well, yeah, exactly. This COVID-19 completely changed commuting. So, I mean, I hope this situation ends soon, but like, yeah, but I mean, my research is designed for normal days.
Fair enough. Hopefully,
Yeah.
as you say, we get back to normal days quickly. Now, just to let me know, you can also continue to put questions in the chat window as we are talking in this Q&A session. So that's just at the bottom side of your screen if you want to do that. And we'll hopefully get on to answering those. But Omid, I have another question here for you. From John, and he has asked, have you considered elevation in the walking model? And he passed a comment that he'd rather walk on the flat than up a hill.
Well, as I said, my measure for commuting length is commute time. So in calculating commute time in the working network I'm using in GIS, I considered elevation, like in terms of slope of the hill. And also I considered some of road regulations, especially for cyclists and public transport and driving. Say, for example, one-way roads and like some roads that are not allowed for special vehicles.
Great, thanks for that, Omid.
Yeah, thank you.
Okay, Omid, I've got another one here for you.
Yes.
Does Household Survey provide details of preferred parking location and their office location, or was this an assumption of the survey?
Well, there is, I mean, Household Travel Survey has data about where they parked at the end of each trip. So yes, they have it, like, for example, for at workplace, they parked either in like office street private parking, office street public parking buildings, or on a street parking with time limit or without time limit. Yeah, this is available. And also New Zealand Household Travel Survey, following a confidential deal we had with them, like provided us with actual workplaces, which was very helpful in our research. Yeah.
Okay. Just a follow-up question with that. The person asking the question said that age is seen as interesting correlation.
Yeah.
How valid do you think that is? Do you think there may be other reasons for that correlation?
Well, I think age represents two things here. The first thing is about kind of the wealth of a household, because usually, like, if the head of household is older, like, it's more likely that they have, like, you know, more savings and like higher wealth. Other than that, like, age also represents preference for convenience of travel mode. So for example, like, people with like elderly people may prefer to, like, you know, travel with more convenient modes of transport rather than, like, you know, using scooters, which is like popular mostly with young people.
Okay, thank you very much.
Thank you.
And Jonathan, I have a question for you. Do the handheld Trimble devices integrate with all of the Esri field apps?
Good question. So I think the answer is yes. Android-based devices are sort of generic in the way that they support, you know, all of the apps that come down from the Play Store. I think the question is how the app then integrates with the GNSS component that you might like to add to that. So if you're using Collector, for example, I know that there's support for a lot of our products embedded in that software. If you're using some of the others, like I think Quick Capture might be one that doesn't have the same level of integration. In that case, Trimble has some utility apps that can run in parallel with the Esri app that can effectively achieve the same outcome. So it can port the Trimble accuracy into the application anyway, even if support isn't you know, embedded in that application technically.
Thank you, Jonathan. That's all our questions that we have for now. So thank you for being here today. If you would like to submit a question after the webinar, feel free to email gistraining@eagle.co.nz, or you can contact one of our presenters directly. Like to just remind people that our next virtual user conference is this Thursday, the 23rd of April at 11 o'clock, and you can visit the Eagle website to register for that webinar if you haven't done so already. If you've missed any of today's presentations or would like to have another look at them, just a reminder, you will be sent a recording of these webinars as an attendee, and you can also go to our GoToStage channel for the virtual user conference as well to get access to those recordings. So it has also been a pleasure to have Jonathan and Omid presenting today. These virtual user conferences are obviously held in collaboration between the New Zealand Esri User Group and their partners, Eagle Technology, GBS, and AllTerra, our newest partner. And the Esri User Group would also like to say a big thank you to those people who were going to be regional user conference sponsors but have turned into virtual user conference sponsors. They are National Map, GeoWorks, Jacobs and First Name. Thank you very much for your sponsorship, and thank you all for your time this morning for this webinar. Stay safe, and we look forward to seeing you online at our next webinar on Thursday, and connecting with you face to face as soon as possible.